everyone. Welcome back to the third part of this screencast about my probability experiments about my new gambling game I've invented called 3UP. So last time I left you, we only had 10 rows in this table. I've extended this now just by copying the formulas in the table down for 100 experiments. The annoying thing about 100 experiments is that I then have to update the formula. I had a formula here last time that only went for the first 10, but I've had to update that formula so it goes all the way down to the bottom of the table. What I would really like to be able to do is be able to select different sections of the table at will. Now, I can do that if I set up a variable here, and let's just put 10 at the moment, as if that n was the number of games. So if I had 10 games, there's no way I'm going to lose $34 in 10 games. So I need this formula here not to point all the way down to L104 when it adds up. I only need it to point down to this one, which is L14, right there. Now there is a way of doing this. What I need to do is use a command in Excel called Indirect. So I've still got the L5 at the top. I've still got the colon, which is telling me that there's a range here of cells which are being added. But with Indirect, I need to put some text inside there. And the text, well, it'll still be a letter L for the column reference. It'll be somewhere in column L. And I have to join on to that the number stored in this cell, the number 10. Now, if I just go to L10, L10 will only be down to there. If I want to actually have that 10 represent 10 games, I have to get all the way down to this one, which is in L14. So I need to have that number 10 plus 14, so it's literally going to add from, and I need one more bracket, it's literally going to add from L5 here down to L14, which will be my 10 games. And if I do that, and if I click on this formula, oh, that didn't help because it's got the indirect in it. But it is calculating. Let's just do as a check. Let's just do separately the sum of the 10 games. There's the 10 games. And they should match each time. Every time I recalculate, they're matching. So the indirect formula is allowing me to just select the first 10 rows as if the player only played 10 games. What if the player did 20 games? Then you see how it doesn't match anymore. That's because the indirect formula is actually getting me to calculate all the way down to the sum of these answers all the way down to here. And if we were to do them manually, we would find they come to -6. So the indirect formula is a lovely way of doing this. Every time, of course, I recalculate, I get a new experiment. The random numbers change. What if I wanted more than 20 games? I could just, whoopsie, that's too many. What if I just put 50 games there? In 50 games, the player has lost $11.50. Of course, to play 50 games, the player must have used 50 $1 bets. Okay. This gives me a way of calculating the house edge. A different way of calculating the house edge compared to what we had over here on the theoretical side of things. I'll go -1 multiplied by this number, because if it's a house edge, it's a profit. That -7 was the money the player had lost, and I will divide that by that number there, because if the player played 50 games, it means they had wagered $1 each game. Now I don't really want that to be money, I'll have that as a percentage. Let's have one more decimal. So after 50 games of experimenting with probability, I've got a 7% house edge. Not exactly the 12.5 I was hoping for, but 50 games is a very small number of games. I can press F9 a few times to see what's going on. See, occasionally the house edge is much higher than expected. Occasionally a bit higher. Oh, much higher. That's a very bad day for our gambler with those 50 games. That 12% was close, but there's another 12%, very close. Now, what if I do 100 games? Well, if I do 100 games, I'd expect the house edge to be still it would be varying because it's random outcomes, but the house edge is, well, it's not jumping up and down quite as much as it was a moment ago. The more games we play, the more likely the experimental outcome matches the theoretical outcome. Now, I've only got my table extended here to 100. It would be much better if I extended the table to 1,000 or 10,000 or 100,000, and then I could still use this little control to decide how many experiments I was observing in my calculation of my experimental house edge. Hopefully we would find that the more experiments we observe, the closer this experimental value is to the theoretical value calculated over here. Of course, because I linked all of these things back to these cells, if I suddenly change my mind about the size of the payouts, everything else will still recalculate properly because these numbers here were linked back to the payouts over in this table. I think that's enough for now, and that's the final one in my series about this. An improvement that I'm not going to make a video about, but which could be done, is to extend this table way further than 100. Maybe it would depend, I suppose, on how much memory your computer has, how much you could do, but I think let's just have a quick look at how far a spreadsheet goes. Well, it goes to well over 1 million rows. 1 million experiments, is that 1 million or is that more than 1 million? Yes, no, that's 1 million. That's 1 million rows. So 1 million rows of this would probably make my computer melt down, but maybe 1,000, maybe 10,000. If I was pushing the friendship, maybe 100,000 rows could be something that my computer would handle. I'll leave you to try that for yourselves. Thanks for watching. See you next time.